Okay, so as I said before, we were looking at lines and we shaded above or below the line on a graph because there were two variables. Now notice we're going to use graphs now with only one variable, but the answer is only x values. Remember that. Okay, so solve. So let's put x minus 2 is less than or equal to 0. And solve. So let's add 2 to both sides. So x is less than or equal to 2. Circle it. So remember, we did this on the number line, which we're going to introduce in a moment, back in grade 9, where we drew the number line and we circled the thing at 2 and put a closed dot or an open dot and shaded to the left or to the right, or just scan down below where the hand is. But we're going to graph it this time. And what we're going to graph is what is equal to 0. Let me say that again. What we're going to graph is what is equal to 0, or greater than or equal or less than equal to 0. So remember that. That's what we're going to graph. So no matter what equation it is, what form it is, it has to be equal to 0. So you either have to get it equal to 0 or whichever, but the notes are on very simple examples. So when we introduce new concepts, it's a lot easier to absorb them. Okay, so again, one more time. It's y equals the exact thing that is equal to or greater than or less than 0. This, x minus 2. So let's graph it. So x minus 2, we have a y-intercept of negative 2. Now we still have to remember that we're doing less than or equal to, so we can do closed dots. So we have a y-intercept at negative 2 on the graph. We have a slope of 1, up 1, over 1. And then I'll put a line through it. So there's that graph of the equation in y equals an equation that didn't used to have y. Also known as graph the left-hand side and the right-hand side, like we briefly talked about in the last chapter. So we're going to graph what's equal to 0 down below. And now, instead of shading above or below, because there's no y involved, we're only shading the number line where it's true. Well, we just, big blue, found the solution down, and let's do that on the number line like we did on the x-axis, like we did on the number line way back in grade 9 and 10. So if x is less than 2, well, we put a dot at 2. I'm going to enforce that dot. And we just shade that way. So why would you do this when you could just do only a number line? Mark 2, put a dot there and shade that way. Put your hand on it like in the notes if you like. We're doing this so then when we do the more difficult ones off to the right, again, we can better absorb more difficult steps when the other stuff is more simple. So again, this is a simple line from grade 10. The parabolas off to the right are going to be more difficult. So we want to graph the thing that's equal to 0. And that's what we're going to do off to the right. But what we now want to do is just remind you what to do to check your answer on the next 2 off to the right. So we're going to pick a value somewhere in this location in the shaded region. And we're going to pick a value somewhere here in the not shaded region. So I just randomly chose 0 and 4. And we're going to put them in to the equation from the beginning. Big blue. Obviously, we only introduced y to graph it, and we only graphed it to more easily allow you to do the harder questions in the future. You wouldn't graph this one. You'd only draw the number line. But let's write that equation down side by side twice. So we have x minus 2 is less than or equal to 0. And again, x minus 2 is less than or equal to 0. Choosing test points in the shaded region and outside. We technically wouldn't know which region is shaded yet. We're just doing this because they're called sign analysis. Well, let's continue. So let's solve each of these equations. Let's add 2. Let's substitute the x values in that we were putting arrows to above. So the first value is going to be 0. So we can put 0 in for x. Now again, remember, we're checking our answers, so we're not adding and subtracting. We're testing the left-hand side and the right-hand side. So we get negative 2 on the left-hand side, 0 minus 2, and less than equal to the right-hand side is just 0. Now, is that a correct statement? Is negative 2 less than 0? Is it to the left of 0 on the number line? Yes. So check mark. And that's how you know you could shade that. And it has to be true. So it's kind of like a test point when we tested the point above or below the line in the last section, but it's only a test point on the number line. So let's test the point 4 off to the right. Let's put 4 in for x. So 4 minus 2 less than equal to 0, substituting 4 in for x. On any point that you'd want to the right of 2, 4 minus 2 is 2. Less than or equal to 0. Is that true? No. No, it's not true. And that's why we're not shading that section. Okay, so remember, we only did all that kind of almost simple stuff to more easily allow us to do harder questions off to the right. So we're going to refer back to some of these and keep in mind their perfect scale that they are right now are no longer. But I did that so I can have my perfect columns. So let's take an example with a negative x squared, top, middle. Negative x squared plus 5x minus 4 less than equal to 0. So I don't like this negative out in front. So I'm going to divide both sides by a negative 1. Now in the notes, I removed the greatest common factor of 1, then divided both sides by negative 1. But I'm just going to do it the lazy way this time. So just divide both sides by negative 1. So we get x squared. Negative x squared divided by negative 1 is positive x squared. 5x divided by negative 1 is negative 5x. Negative 4 divided by negative 1 is positive 4. We divided or multiplied both sides by a negative, so we have to change the direction of the sign. 0 divided by negative 1 is just 0. Remember, these things have to be equal to 0, or greater than equal to, or less than equal to 0. So you can start doing these things like multiplying or dividing both sides by numbers and cleaning them up a ton. So now we're going to factor it from grade 10. Two numbers that multiply to get 4 and add to get negative 5 are x, both negative, minus 4, both negative, minus 4, and x minus 1. I'm going to move that 1 a little bit to the right of that negative. Minus 1, greater than equal to 0. So remember, set your factors equal to 0 and solve. Oh, look at that. I actually did it in the notes. Remember, it's done in the notes so many times in previous chapters of solving quadratic equations that we're going to skip steps in the videos. So we get x equals 4 and x equals 1. No lazy x comma 1s. X equals 4 comma 1s. So those are our two x-intercepts, so I can graph it. Now remember, there's still no y involved. Ooh, excuse me, my notes. I've got to move that y-axis over a little bit. Sorry, I hope that you guys are doing better page layout than I am. Or just using separate pages. I'm just making sure the videos look exactly like the notes after, whichever. So the x-intercepts are 1 and 4, so I should have known to draw the y-axis over a little bit. All good? I can draw the x-axis. And we can put x-intercepts at 1 and 1, 2, 3, 4. Use graph paper all the time. Whoa, excuse me. We haven't been equal to the whole time. Let's erase these 2 points that we just drew. And everywhere above, all three examples, don't write this. Erase the negative there, or excuse me, the greater than, the equal to there, and one more time there. So lightly, I'm going to erase all of them. I'm going to put the sign that was in the notes the whole time. It was only less than. I got carried away from the last question. So, still less than. No, excuse me, we divided by a negative, so change the direction of the sign, and then still the way it is. And then notice we treated it like an equal sign when solving for the x-intercepts. And now, because in red I corrected it, it was just less than. I can erase these ridiculous blue arrows over here. And you can see what I just corrected. Make sure that you just corrected those to all be less than divided by negative. Change the direction of the sign. Greater than stays greater than. So our x-intercepts are open dots. So we're going to put an open dot at 1 and an open dot at 4. Now I don't really care what the rest of it looks like, so I'm just going to draw a dotted line parabola like we learned from back in the previous section and grade 8, 9, and 10. So there's the parabola, their x-intercepts, and that. So what I can actually do is look at this line above, technically, or this one, and I can call the left-hand side the thing. And I can say, when is the thing greater than 0? Well, what do you mean by greater than 0? We mean greater y values. I know there's still no y involved, but we're introducing what's equal to 0 on a graph, like we just did off to the left very slowly, to ask ourselves, when is the graph true? So, when are these big red equations greater than 0? In the graph, here and here. Now, we can just easily shade the x-axis in the direction of those parts. And then draw an identical number line directly below. And put 1 and 4 exactly below where your x-axis was directly above. Put open dots there, and then shade in that same direction. And that knowledge, being able to graph it, and just think, when is the thing greater than equal to 0? Off to the right, we're going to do the example where it's less than, and we're going to circle below, and it's going to be a different type. Either way, let's answer this question. So we're just going to state the domain, like the only part that mattered in the question off to the left that we just did was isolating for what x was above. So the only answer is what x is, because there was never any y involved. We just introduced it to allow us to graph it to more easily find out what the solution was, rather than do all the crazy algebra down below. So we can just state what the domain of the shaded parts are near the locations of the shaded parts. So x is less than 1, circle it. X is greater than 4, circle it. Not equal to, because the question above is not equal to. Okay, now as I do sometimes, I'm going to bring in the notes for reasons. So we just did the middle example, and we just got to here, and we just got to the number line. We graphed it and then did the number line. Oh, and then I answered the question for you already, but I put the answers down here. I should have put those near the number line, but I think I did that for reasons. Now, what we don't want to have to do is all this pick a value sign analysis. We'd rather just use our graphing ability to know where to shade. But you could do the thing that we just did off to the left bringing it back to where we were. So you could do all the sign analysis down here like we did up here, but it's so boring and annoying. So your teacher might force you to do it, which obviously you have to do it. But outside of that, if you can just give them the answer, or her, then this is a much simpler way. So that's why we went so simply on the example off to the left, for reasons as to why to graph it. Because it's way easier just to ask yourself, when is the thing greater than or less than 0? So now let's see an example where it was greater than. Less than. Notice this first example was less than, and we could have graphed that and we would have got the same solution, but it would have been opening downwards. I like to have my parabolas opening upwards, and just remember when you divide both sides by -1, change the direction of the sign. Okay, so we're now on to the third example. That's not going to work very well. Let's try that in a different fashion. Let's get some mouse action out here. Okay, that's not going to work either. Oh, I bet it's this gigantic circle. I'm going to get rid of this circle and this arrow. Okay, so I'm going to try and get all this stuff lined up for fun. I didn't have to shrink it that much vertically. I'm just going to go horizontally this time. Okay, so I hope that you can fit this. If you can't, just go onto a separate sheet of paper. I just want it to be all lined up like the notes. And when you are trying to write it like I am, try and follow the notes a little bit. Okay, so an example off to the right, let's go for x squared minus 4 less than or equal to 0. Seen this one before. Factor the left-hand side, x plus 2, x minus 2, x minus 2, less than or equal to 0. Find your x-intercepts, x equals -2, setting your factors equal to 0 separately and 2. So we have the x-intercepts, we can graph the thing. Putting on our x-intercepts at -2 and 2. And then drawing our parabola. I mean, if you remember the patterns, you'll know where the vertex is, but we're just not concerned with that because y is not even here anyways. So now we're going to put an arrow to the above equation to remind you the thought process. When is the thing? When is this thing less than or equal to 0? Well, it is down here. So we shade that part. Now this is a between. Go back to grade 9 and learn how to do a between. We do lower number, less than, equal to if necessary, variable, less than, equal to if it's necessary, bigger variable. Circle your answer. Ooh, excuse me, I forgot to shade the number line directly above. I forgot to draw a new number line directly below and put my -2 and my 2 exactly in the same locations where they were above. And then also shade that part to more reinforcedly see how easy it is just a between. So again, we just graph it so we don't have to do all this sign analysis in the notes. Again, if they force you to do it, do it. Whichever. Okay, the last English sentence at the bottom of the page, I just want to read very carefully. The answer is only the domain. The number line in the graph is only to help. There is no y involved. In the last section, we saw linear inequalities, lines, in 2 variables, where we shaded above or below the graph, and that was the answer to the question. Here, the answer is only big blue at the bottom. The domains. All we care about is the domain because we're only talking about x. All the equations at the top only have x in it. We only introduce y to more easily see where we shade on the number line identical to the x-axis on the graph above it, and then just answer the question according to the domain. Okay, so now we're going to go bring the last section back into it and start to shade above or below again in 2 variables with lines and parabolas.